Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize patterns in arithmetic sequences and write their corresponding sequence equations, and how to find a given term for an arithmetic sequence, as well as how to recognize patterns in geometric sequences and write their corresponding sequence equations, how to find a given term for a geometric sequence, and how to convert arithmetic and geometric sequences between explicit and recursive forms. How are we learning it? Through the Arithmetic and Geometric Sequences Review Notes and the Arithmetic and Geometric Sequences Review Assignment. When can we use this information? To recognize patterns in order to recognize trends in the stock market or housing rates, and to re-examine issues in your life in different ways so that you can find the most appropriate method of solving the problem. How do you know you learned it? By getting a score of 4 on the Arithmetic and Geometric Sequences Review Assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Arithmetic and Geometric Sequences Review Notes, and then I'll give you time to complete the Arithmetic and Geometric Sequences Review Assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to work on any incomplete assignments that you may have. Let's take a look now at the Arithmetic and Geometric Sequences Review Notes. The notes begin with the learning goals and success criteria. What is an arithmetic sequence? An arithmetic sequence is a sequence of numbers in which each term is found by adding the same number to the previous term. So an example of this would be 2, 4, 6, 8, 10, etc. So each time we move from one to the next, we're adding 2 to it. So 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, and so on, and it goes on forever. Notice that there's a common difference of 2 between each term in the sequence. So let's take a look at the table. So we have our months, and we look and see that there is a steady change. We're adding by 1 month each time. And in rainfall, we can see that we have a consistent change also. We are adding by 2 inches each month. Therefore, if we were to plot these points, it would look like this, and therefore we can see it does form a straight line, and yes, it is linear because we have a consistent change of addition and a consistent change of addition. So predicting a pattern, so if we're given the pattern of 2, 4, 6, 8, 10, and we're asked, what is the common difference? Well, we should notice that every time we go up 2, so the common difference is 2. So the question is, what would be the next term in the sequence? So after 10, what would be the next one? So we know that we're going up by 2 each time. So we add 2 and we get 12. So the next term would be 12. Again, we have a situation where we know the common difference is 2. Now, what if I asked, what is the 8th term? So we have 1 term, 2, 3, 4, 5. So we need 3 terms later. So we're going to go ahead and add 3 terms. So we add 2 and 2 and 2, and we get 16. So we know that the 8th term would be 16. Now, is that always easy to find? No, depending on the term, we don't want to have to keep calculating out. So the easiest way to do this is to write it in explicit form. So the explicit form for an arithmetic sequence is a to the n, meaning the value that we're trying to find, is equal to d, the common difference, times the number that we want, minus 1, plus the first term in the sequence. So an is the term we're trying to find. So for instance, a7 is the 7th term in the sequence. D is the common difference. N is the number of the term that we're trying to find. And A1 is the first term in the sequence. So let's look at an example. We have a pattern here, 2, 4, 6, 8, 10. The explicit form then is AN is equal to D times N minus 1 plus A1. Well, we know D and we know A1. So we know D is 2, that was the common difference. And A1 is 2 because that's the first term in the sequence. Now let's take a look at this one. So we're given that AN is equal to 3 times n minus 1 plus 4, and we want the 5th term. So 3 is our common difference, 4 is our first term, and we want the 5th term. So we're just going to plug 5 in for n. So this becomes A5 is equal to 3 times 5 minus 1 plus 4. Now we're just solve it. So 5 minus 1 is 4. So we're left with 3 times 4 plus 4. Well, 3 times 4 is 12 plus 4 is 16. So the fifth term in that sequence would be 16. So look at another example. Let's try to find the 10th term of this one. That's an is equal to negative 4 times n minus 1 minus 3. So again, we plug in 10 for n. So this becomes a10 is equal to negative 4 times 10 minus 1 minus 3. Well, 10 minus 1 is 9. So we have negative 4 times 9 minus 3. Well, negative 4 times 9 is negative 36 minus 3. Negative 36 minus 3 is negative 39. So the fifth term in that sequence is negative 39. There's a video here that shows you how to find the common difference for an arithmetic sequence using Symbol Lab, so you can watch that video. Let's take a look now at how we can find a common difference from an arithmetic sequence. So we went to Symbol Lab and went to their arithmetic sequence calculator, and we're going to go here to where it says common difference. And it asks, what's the sequence? So we're going to put in the first 2 or 3 terms. So if it's given as an equation, that's okay. We'll just figure out what the first couple terms are. So let's say it's 3, 7, and 11. So that's our sequence. And we can go ahead and click go. And it will tell us everything we need to know. So it'll write out the equation for us. This is what it should look like in the equation. And it tells us D what the difference is. The difference is 4. So this is how we can use Symbol Lab to find the common difference for our arithmetic sequences. There's a video here that shows you how to find a given term in an arithmetic sequence. So you can use this to check your work. So you can go ahead and watch this video. Let's take a look now at how we can check our work using Symbol Lab to find a given term in an arithmetic sequence. So we go to Symbol Lab and we go to the arithmetic sequence calculator, and we're going to click on the one that says value given index. So I'm going to click on that one, and it asks us for the sequence. Now it prefers to receive the sequences in terms of numbers. So if they give you the equation, that's okay. Just find the first 2 terms. That's all you really need. So I'm going to go ahead and put in the first term as 2 and the second one as 7. And then I'm going to put in the term that I'm looking for. So let's say I'm trying to find the 9th term. So I'm going to go ahead and enter that in, and I click go. And if I scroll down, it gives me the equation here that I'm looking for. And then it computes it for me and tells me that the 9th term should be 42. So this is how I can check my work using Symbol Lab when trying to find a given term of an arithmetic sequence. What is a geometric sequence? A geometric sequence is a sequence of numbers in which each term is found by multiplying the same number to the previous term. An example of this would be 2, 4, 8, 16, 32. What you should notice is every time we move from one term to the next, we have a common ratio or a multiple of 2. So we're multiplying 2 times 2 to get 4, 4 times 2 is 8, 8 times 2 is 16, and so on. How can we recognize exponential functions from a table? Well, first of all, the rule is the number of months, my x values, should be changing by a consistent amount, and it should be addition. And my y values should be changing by multiplication. So in this case, we have the months. So this is 1, 2, 3, 4. Well, is there a steady change in the number of months? Yes, there is, and it's changing by 1 month each time. Now here we have 2, 4, 8, 16. There is a steady change, and it is multiplication. We're multiplying by 2 each time. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So we're seeing a steady change, and it's multiplication. It is doubling, or multiplying by 2 each month. So therefore, is this exponential? Yes, it is. And if we were to plot these points, it would look something like this and form this curve. So we're given this pattern, 2, 4, 8, 16, and 32. And we want to know what the common ratio is. Well, we already talked about it earlier. Our common ratio is 2, and we found it by dividing this number by this number. So 4 divided by 2 is 2. So that's our common ratio. So what would the next term be? Well, we would take 32 and multiply by 2, and we get 64. So 64 would be our next term. Again, let's look at another example. What is the common ratio? We know that the common ratio is 2. Now, what would the 8th term be? Well, this is the 1, 2, 3, 4, 5 term. So we need to multiply by 2 3 more times. So this is 32 times 2 times 2 times 2. When we multiply that all out, we get 256. So our 8th term would be 256. Now let's talk about the explicit form for a geometric sequence. The explicit form looks like this. an is equal to a1 times r to the n minus 1 power. An in this case represents the term we are trying to find. For instance, a7 would be the 7th term in the sequence. R represents the common ratio. N represents the number of the term that we're trying to find. And A1 represents the first term in the sequence. So if we're given a pattern here, 3, 6, 12, 24, 48, we go ahead and fill this in. So AN we don't know. We do know A1 and we do know R. So AN is equal to, the first one is 3, and the R value we're multiplying by 2 each time, so R is 2. So this becomes 3 times 2 to the n minus 1. Now let's take a look at an example. We have AN is equal to 3 times 2 to the n minus 1, and we want the 5th term. So we're going to take that and we're going to plug 5 in for n. So this is A5 is equal to 3 times 2 to the 5 minus 1 power. Well, we know that 5 minus 1 is 4. So we have 3 times 2 to the 4th power. Well, 2 to the 4th power is 16. Then we multiply that by 3 and we get 48 is our answer. There's a video here that you can watch on how to check your work when trying to find the common ratio for a geometric sequence. So go ahead and watch that video. Let's take a look now at how we can use Symbolab to find the common ratio of a geometric sequence. So we're going to go to symbolab.com and then we're going to find where it says Geometric Sequence Calculator. And I'm going to click here where it says Common Ratio. And it asks for the sequence. Let's say our sequence is 3 and 9 and then 27. So those are the 3 that we know. I'm going to go ahead and click Go. And it will tell me the equation right here. So it tells me exactly what the equation is. It should be a sub n is equal to 3 times 3 to the n minus 1. And it tells me exactly what my r, or my common ratio, is. My common ratio is 3. So this is how I can use Symbolab to find the common ratio of a geometric sequence. There's a video here that shows you how to check your work when trying to find a given term of a geometric sequence. So go ahead and watch that video. Let's take a look now at how we can use Symbolab to check our work when trying to find a given term of a geometric sequence. So we're going to go to symbolab.com and then we're going to go to the Geometric Sequence Calculator. And then down here I'm going to go to the one that says Value Given Index. And we're going to enter our sequence. Now, you may have the sequence been given to you as an equation. That's okay, just fine, like the first 2 terms, that's all you really need. So let's say the first term was 4 and the second term was 18. And the term we want is the 7th term. So we just enter our sequence in here and put our index here. Index is the term we want. And we're going to go ahead and click Go. And when we scroll down, it tells us exactly what our ratio is and exactly what our term should be. So our 7th term should be 531,441 over 16. So this would be our solution. So that's how you can use Symbolab to check your work when trying to find a given term of a geometric sequence. Now, how can we predict the next term in a sequence? So let's say we know the 20th term. How do we know then what the 21st term would be? So the way this works is we're going to find the next term in the sequence if the previous term is 57, given that an is equal to an minus 1 plus 4. So what we're saying is the term we want is equal to the previous term plus 4. So we know the previous term is 57. So we're going to plug that in for this one that represents the previous term. So we have 57 plus 4 is equal to 61. So that's how we use the recursive formula to find the next term. Now let's take a look at the recursive form for a geometric sequence. So that follows this pattern. an is equal to r times a to the n minus 1. Now, what we're really saying here is the term we're trying to find is equal to the common ratio times the previous term. So if we look at this one, we have an is equal to 4 times negative 1/2 to the n minus 1. And we want the fourth term. So we start here, and we're going to plug in 4 for n. And we get negative 1/2 to the third power. Well, when we multiply that out, we recognize that negative 1/2 to the third power is equal to negative 1/8. We multiply that by negative 4, and we get positive 1/2. So that would be the term that we're looking at. So let's look at an example here of working with recursive formulas. So we have an is equal to 3 times a to the n minus 1. And we know that the previous term is 21. So we plug 21 in here. So we get an is equal to 3 times 21. Well, we know that 3 times 21 is 63. So an is equal to 63. Let's take a look now at the arithmetic and geometric sequences review assignment. The assignment begins with the learning goals and success criteria. If I scroll down, I can see the questions. The first one says, what type of function is similar to an arithmetic sequence? Well, we know that it's going up by addition, so if we think back, we should recognize that that's similar to a linear function. So we'll go ahead and put that as our answer. Next one, what should be the next term in the arithmetic sequence below? We have 24, 19, 14. Well, we can see we're going down by 5 each time. So 14 minus 5 is 9. So we'll go ahead and put that as our answer. And we'll continue to answer these questions all the way until we get to the end of the assignment. Once we get to the end, we'll go ahead and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.